Okay, so let me start this optical fibers. Of course, the title itself you see a need and greed of the present day. Okay, so let me move to the forward next one, history. So this is also we are discussing several times whenever the new topic we are going to start, we must know the history part so that we have some rough idea about the techniques or the utilities. Okay, so if you look at the history part, so the first experimental proof, let me annotate it also so that it may be very clear for you. Yeah. So you see the first experimental proof that the light could be guided, okay, along a stream of water. So you people are familiar with that experiment that was provided by Tyndall, and people are knowing as a Tyndall effect also sometimes. So John Tyndall has have demonstrated that light can be guided in a particular path, okay. So, and that too you see around 120 years ago or even more than that. And secondly, if you see, so this was the idea behind this particular setup principle. And now look at the second. So the first glass fibers, okay, that made in 1920s. Remember this particular history because then only you will understand the importance of a particular thing. Okay, we'll discuss all such things in more detail. So first glass fibers were made in 1920s, but you see the concept of cladding came in 1950. So what is cladding, etc. That we'll discuss again in more detail. But simply you see that this first glass fiber they made in 1920. But see, after 30 years, they come out with some another concept of cladding. Okay, you see 1920 and 1950. And then you see in the early 1960s, after around 10 years of this, okay, cladding part. So passing light through the fibers, okay, was confined only to the scientific studies. So this technology was existing, okay, precisely after 1950 or something, okay, and scientists were working on them on the technology, and in the early 1960s they were capable to use this technology in scientific studies. Okay, why we restricted ourselves to scientific studies? Because it was in the early development, and there may be so many limits of that particular technology, but for a scientific study that can be useful. Okay, but for normal use it was not possible to use in our daily life. Okay, so coming to this, why it was very difficult to use in normal life. So you look at, so at the time around 1960, some of the best optical glasses that had attenuations in the sense, basically it's a technical word, okay, scientific word, but the meaning is loss. Attenuate होना मतलब कि loss होना. So optical glasses or that fibers has losses, okay, of the order of, you see, several thousand dB per kilometer. You remember this word several thousand. So I'm talking about in 1960, okay, around 1960. So there you see. So if you remember, then all such losses or gain, right, we are discussing in terms of dB. So it's a very common unit of representing the gain or loss. So you see the losses are in several thousand dB per kilometer. dB is the decibel. Okay. So that is why it was very difficult to use in daily life, because if this much large losses are there, then it is not suited for daily life. But in scientific studies where only we are focused for towards a limited content, so one can obtain this kind of setup also. But then this was the beginning also, one can consider. And now you see the last one. So they thought of that in scientific study, that is okay if we choose several thousand dB per kilometer, losses are there, still they are using that system. But if they want to use in all such futures or all future communication devices, right, tactical systems, whatever they have in the future, so then they thought that it may be possible only if this attenuation, which is earlier several thousand dB per kilometer, if somehow they could be brought to a level of 20 dB per kilometer. So you see the huge difference, right? Several thousand dB per kilometer they were having, or they were facing during that 1960 around, but they were expecting to bring it down to 20 dB per kilometer. And if they do so, they can be useful, or this technology can be useful for our daily life. So this was the idea or the history behind that. Of course, it is many more, but let me limit to this moment itself. Okay, so several thousand dB per kilometer to 20 dB per kilometer, if we achieve it, then we can use in our daily life. Okay, so all such things we'll discuss again, like what is cladding, etc. So don't need to worry, let me go through the theory part. Okay, so once history is covered, then we'll discuss all such concept in details. Yes, Hello. Yeah. Okay, so for this you can refer the NPTEL lectures or NPTEL video contents are there. I prefer that one, but otherwise in general, all such optical fiber books, I mean, you can refer any book which you can find. Okay, because optical fiber content is in proper depth in every book. Okay, so I preferred NPTEL content mostly. Now come to the next. Okay, yeah, first. Okay, so here we'll discuss about the basic idea of any communication system. Okay, so it is well known, right? If you want to pass on the message, if you want to pass the information to the another side or transmit to the other side over a particular distance, then you require a system. Suppose if you say that you want to transmit a particular signal from Ahmedabad to Surat, let's say, fine. So you required a system. So that's via the system only you can transfer that particular signal, which is in form of information. You can transmit to the another side over a certain distance. Okay, so Ahmedabad to Surat, let's say 200 or 230, 40 kilometers are there. So you required a system basically to transfer that. So what is the basic component of a system, or what are the things you required in a system basically? So you see, let me annotate one more time for you. Here it is. Okay, so it is made possible, this communication can be made possible by modulating or superimposing. I hope again that you people are familiar with this modulating or demodulating concept as well as superimposing. Okay, there are several types of modulating: frequency modulation, wave amplitude modulation, phase modulation. So all such things are there. You have already gone through that. So here I am discussing in general that it is made possible by modulating, or simply one can say superimposing the information on the electromagnetic wave, okay, which will be acting as a carrier. Okay, so sometimes people are saying as a carrier wave also, because that is carrying your signal. Okay, so that is what you required. Yani you need to modulate your signal or information onto the carrier wave so that it can carry your signal to the other side. And now this modulated carrier wave, okay, then transmitted to the destination, okay, where it is received, and the original information is obtained by demodulation. So you see the techniques. To send any signal from one place to the another place, you need to modulate onto the carrier wave, and that carrier wave is nothing but basically electromagnetic wave. Okay, and then you need to transmit to the other side through some medium. Okay, it may be optical fiber also, it may be air also, whatever the medium depending on the case. So via some medium it has to transfer to the other end, and at other end you need to receive that signal. Okay, and then you need to demodulate it, then only you will get the original content or original information which is there in the signal. So that's how, this is the general idea behind any communication system, not only the optical fiber I am talking, but any general system you think of, and this is the base you consider. Okay, so let me come to the another part: capacity. Okay, this is also very important. Capacity of a system. Why we are discussing all such little terms? Because this makes you people, because since you are in the engineering program, okay, so you must know how to build a system and what may be the capacity. Suppose after a year, after a my I mean this year itself, or maybe within a 4 year time, or maybe after 4 years of engineering, you want to do, or you want to do some startup or something, right? You want to create some system, so you must know the capacity of your system whichever you are going to build in the future. So that is why this is very important, all such things. Okay, so in the earlier slide we discussed the setup which required to communicate from one place to the another place. Then if you have decided, then you must know the capacity of your system, how much data it can handle, right? So that is why you see over here, the information carrying capacity of a communication system is directly proportional to its bandwidth. Now remember, this bandwidth is, that means I am talking about the frequency range. Bandwidth is nothing but the frequency range. That means larger the frequency, or larger the range of frequency, that means more information you can transmit to the another end with that system. So that is why this capacity of a particular system, we are generally dealing in terms of bandwidth. Here in the case of optical fiber, we are saying bandwidth because it depends the frequency range, how much it can cover. So you see, the wider the bandwidth, the greater is the information carrying capacity. So let me give you a very simple example to understand this bandwidth concept. Okay, so you people are aware with this 4G technology. 4G we are using in our mobile phone. Okay, before that you people also heard about 3G. उसके भी पहले 3G के पहले भी आपके पास 2G भी था और पॉसिबल है कि 1G भी हो. Okay, so these are the technologies. Now let me differentiate between them with very one simple example. Okay, so you see in 1G, if it is there, then the speed will be very less. Okay, in 2G speed will be slightly large compared to 2G. In 3G again speed will be slightly, not slightly, but of course very large compared to 2G. But in 4G again you see the speed will be higher compared to the 1G, 2G or 3G. Even now we are expecting 5G. So what is the difference between all such techniques, 1G, 2G, 3G, 4G, and suppose let's say in future 5G is also coming. So basically it all depends on the bandwidth. Okay, so how to define the bandwidth? Let's take one more example to clear it out. Okay, so suppose you are in a particular room. Okay, you can consider your room also. Okay, so in that particular room, not your room, but you consider a classroom basically, to simply say. Suppose a classroom is there. Okay, and having the strength of 60 to 75. Let's say you consider your class, for example, let's say 70 strength, we say. So 70 number of us students are there in that particular classroom, and you suppose that there is only one door to enter into the classroom or come out from the classroom. So only one door is there. Okay, now what happens if I say that within a particular time, let's say 1 minute time interval, all 70 students need to come out from that particular door. Okay, or even you consider very less time, not 1 minute, but let's say less than 1 minute time, you need to come out from the classroom. Okay, then what will happen? So many people, so many students try to come out from the same time from that particular door, but there will be some dhakka mukki kind of thing, right? Why? Because everyone want to come out from within the time interval, but it seems to be very difficult because the door width is very limited. Okay, so at one time one person can pass out from the door. Okay, if we consider the door width is limited, only one person can come out from the door at a time. So you see within 1 minute time it will be very difficult. Everyone was trying to out from the classroom using the door, but it seems to be very difficult because that is the case of 1G. Now you remember that number of users are more. Okay, but at the same time the frequency range is very small. So here in this case, you people are in the strength of let's say 70, but at a time only one student can pass out from the door. So you see, each one of you will be fighting with each other to go out. So and that is why the same thing is happening in the case of 1G. That number of users are more, but
Sir, you are not audible, sir. Your voice is gone.
So we can't hear you, sir.
okay, so what I was saying is, all of you, I think now you can hear me properly, right?
Yes, sir.
Yes.
Yes, sir.
Okay, so what I was saying is that within a particular time interval, okay, within 1 minute or less than 1 minute, all 70 want to come out from that narrow door, okay, which has limited width. So what happens in that case? If you do so, there will be a lot of fighting between you people to come out from the door as early as possible. So that is the case of 1G, where so many people are trying to access, but the source, or let's say the frequency range, is very limited, and that is why they are not getting the proper speed in 1G. Now coming to the second case, okay, let's say 2G. So what happens if I increase the width of the door? अगर मैं width थोड़ा सा और बढ़ा दूं, then so many people can pass out. Suppose मैं उसको जो single person pass out हो रहा था, if I make it double, like 2 person at a time can pass out through the window or through the door, then of course more feasibility will be there compared to the 1G case. So that is how what I did is I just increased the range. I just increased the width of the door. That is what in 2G what we done is we just increase the frequency range or let's say bandwidth basically. Right? Same way you consider the case of 3G. That means again you brought that particular door. Okay, उसकी width और आप बढ़ा दो. So more number of people can pass out at the same time rather than one. Now two, three or four person can pass out. Similar way अगेन आप वो थोड़ा उसको चौड़ा कर दो. लेट से आप एक पर्टिकुलर वॉल पूरा ही हटा दो. यू रिमूव वन पर्टिकुलर वॉल ऑफ क्लासरूम completely. Then all such student can move out at the same time. So that is how this is you are just increasing the band, okay, increasing the frequency range, increasing the door width, so that more number of users can pass out from the system or more number. Same way if you talk about in the system, then more number of people can access the data at the same time. Okay, so let's come to the same 1G, 2G, 3G, 4G. So in 2G, what happens? Frequency range was slightly large compared to 1G. So people are having easily can access the internet. But you see, number of users are going more and more. So you require larger bandwidth. So the after a certain time, the 2G will not work. That is why this 3G technology come. In 3G, they just increase the bandwidth. So again, people are happy that yes, I can get access the internet with higher speed because the bandwidth is large. Similarly, after certain time, again people felt that 3G is also not going to work. They required 4G. So again, they increase the frequency range. Okay. So that is why I told you if you want the higher information or high speed internet connectivity or something, you require the larger bandwidth. Okay. And that is the reason people are saying that if you want to take the internet connectivity at home, then you require 2 Mbps speed or maybe 20 Mbps speed or something. So you see that is the bandwidth. So larger the bandwidth, that means larger the speed or the information carrying capacity. So that's how you need to build it up. Okay. So those who are planning to do something, some startup or some system they want to design after 4 years of engineering, it is advisable that whenever you look, you have to look out from for the future perspective. Okay, so you have to prepare a system in such a manner that it can cater to at least another 10 to 15 years demand. Okay, it is not like you present a system with the current demand, otherwise it will be absolute after 2 to 3 years. So you have to design your system keeping in mind that it can serve at least 10 to 15 years purpose. Right? So you note it down this particular part. So that's how this capacity of a system is very, very important. Okay. So now coming to this main part, this is the message behind this capacity part of the system I discussed with you people. Now come to this main thing, fibers. So these fibers have extremely low loss. Okay. In today's case, low loss about you see this kilometer. There's one thing. Let me move it to the other side. Yeah. So you see carefully this particular fiber. Okay, they are having very low loss, 0.2 dB per kilometer. Okay. So if you remember earlier, I told you in the early 1950s or 60s, somewhere they have several thousand dB per kilometer. Okay, that was the loss. But now today's case, you see the losses are very less. Okay, it is 0.2 dB per kilometer. Earlier they thought also that even though if we bring these losses about 20 dB per kilometer, then also one can go for daily use. But you see in the current case, now we are having around 0.2 dB per kilometer, or sometimes it may be less also because this data is also maybe around few years ago. So you can also find it out more what is the current limit or the current loss we are having in the optical fibers. Okay, so you see if I convert this into the percentage something, so that is 0.5 percentage of power loss over a distance of 1 kilometer. That means if you send your signal over a distance of 1 kilometer, so 0.5 percentage of your power which is you supply in the beginning, okay, that is going to be lost over this distance. So but otherwise simply you consider this dB scale because dB per kilometer is the perfect answer rather than in the percentage. So you see, it's very, very small compared to the earlier case. Now, there is also one learning lesson people say over here that whatever the device or the technology you are working on today, it may not be possible to get the result immediately or maybe within a few years. Okay, you need to keep on working. So you can think of what about you see this process has been started in 1920 and then go on 1950, 60, slowly development happened. And suppose the person who was proposing this theory of optical fibers, okay, for the principle, and suppose he just give up. For example, you just gave up this theory, then what will happen? We are not able to know such kind of setup or systems in our daily life. Okay, so that is why whatever the task you do, whatever the system you are going to build today, okay, so you have to keep on working on that. Whatever the flaws may there in that system, you need to keep on solving that. Okay, then only your system will be perfect. But it may take a lot of time. Remember, so that is why a direct message to you people I want to convey that because you are from the engineering domain. So whatever you do, at least do with full accuracy. Even though some flaws are there, fine. You need to keep on working on that, and ultimately, after a certain of year, okay, definitely if your technique or system is very good, then it will give you the output. Okay, so always think for the future terms, okay, future perspective, not only just 2 to 4 years something, at least beyond that, whichever way you can think of. So that's what the message I want to convey with that because this is really very important for you people. Now come to the next part.
जब पता ही था कि लोअर बैंडविड्थ में कम कैपेसिटी
Restriction.
रहती है तो पहले से ही क्यों ज्यादा
Okay.
बैंडविड्थ
So
वाला
here you
नहीं लिया
see this
1G 2G में?
optical fiber case. Here in this you see all such things. Outer jacket. Let me annotate for you people also one more time. Okay. So you see at the center part, this one, right? So this is your core, which we are knowing as the central part also. Yeah, just 1 minute. Someone is having some doubt in the earlier slides. Let me go through that.
सर इससे भी पहले वाली
Please ask if you have any doubt or you write into the chat box.
सर बिफोर दिस वन
No, I was not able to hear. Just wait a minute. Just wait a minute. Yeah. Now can someone repeat again?
सर बिफोर दिस स्लाइड
Okay, just 1 minute. Okay, this one. This one you are asking.
नो सर दैट डेसिबल वन द लॉस वन यस
This one. Yes.
Yes.
See, all such data are available on the internet. Even I have also taken from some sources from the internet only. Okay, but these data are keep on changing, so you cannot always think like this. कि ये fixed number है. Okay, these may vary. Fine. So no need to worry with that. You have to check with the latest one, whichever you can access.
हेलो सर,
Yes.
जब हमें पता ही था कि लोअर बैंडविड्थ में कैपेसिटी कम रहती है तो पहले से ही क्यों ज्यादा बैंडविड्थ वाला यूज नहीं किया 1G 2G में? व्हाट वाज द
Well,
रीजन?
that is perfect because no one has imagined that the requirements are so large in the coming years, right? Even though if you try to create some setup, then you will be looking for at least 5 years future perspective, right? But no one expected like so many internet users or customers will be there who are getting the internet access. No one even, right? So that is what, and that's why I told you that whatever you devise or you create something, you have to be thinking for the at least 10 to 15 years ahead. Then only your device will be, your system will be survived. Otherwise, after a few years, it will be absolute. Okay, so it is not like people have not visioned it properly. They have thought, but again, the number of users are expanded very rapidly. Okay, so that is the thing. And sometimes it also depends on the available infrastructure which you have. Okay, so these are the things which are there. You have to keep in mind always because we are thinking like we need to create a system which can sustain up to the 50 years time, let's say. But you need to look at the current technology also because do we have that resources, the technology with us that can survive up to the 50 years? Okay, So that is why these all things are there you need to consider before going for such long project. Okay. But of course, at the time, you need to keep on changing the things.
Okay, sir.
Okay,
Thank
yeah. Then let me move it to the further. So I was discussing this one. Yes.
Sir, in the previous slide, I have doubt.
Yes, please.
The capacity one.
Yes.
So the slide hasn't changed.
Okay, let me move it to that. This one?
Yes, sir. Sir, it is
Yes.
written that fibers have a loss of about 0.2 dB kilometer, but it
Yes.
should be dependent on wavelength. Shouldn't it be?
Yeah, I have talked about in general, right? There are so many factors are there. Okay, I have not gone through in that factor part. I have talked about in general part. Of course, there are so many parameters. So we'll discuss whichever is possible in the syllabus. We'll discuss. Otherwise, there is a full complete subject on this optical fiber is there. Okay, where you can discuss all such parameters in proper depth. But it is a complete full subject. So you need to spend around again 30 to 40 lectures to understand the optical fiber system in depth. Okay,
Okay, sir.
yeah. So let me come to the next one. Okay, I was discussing this. Okay, so let me annotate one more time. And you see, this is the cladding. Okay, and sorry, this is the core part, central part of this particular cable that we are knowing as a core. Okay, on the top of this core, we are placing a layer, again a different layer of material that we are knowing as a cladding. Okay, now what is the material? That all we'll discuss again in more depth, but at this moment you see core is there, which is the central part of the wire. Then we are putting the cladding on the top of that, and on the top of this core and cladding again we are putting certain layers. So one is saying, people are saying is a coating, somewhere people are saying is a strength member also on the top of that again, and on the top of that again a outer jacket will be there. Okay, so many a times in certain books people have only three components to display. One is the core, second is the cladding, and the outer three, these outer three will be, they are considering as the outer jacket only. Okay, because all these upper three are the part of outer jacket to protect your core and cladding. So rather than putting differently like coating, strength member, etc., one can consider directly as the outer jacket, and the purpose of outer jacket is to protect your core and cladding part. And that is why they are discussing about this core, cladding, and outer jacket in many of the books. But again, if you go through in details, like what is the component of outer jacket, okay, what are the layers in the outer jacket, then you can find this coating part, this strength member, like this. So basically these are all in layers. Okay, so collectively people are saying as a outer jacket, so don't need to worry with that. Important thing is this core and cladding, and remaining part will be the upper layer, which we are knowing as the outer jacket to protect core and cladding part. Let me come to the another case, components. Let's discuss again in proper depth now. Okay, so you see the first part, that is core. This is the core part. It is the highly refractive central region. As I said, it is the central part of a wire. Okay, it is highly refractive central region of an optical fiber through which your light is transmitted. Now of course it is very clear to you people that this is the core, where from where your light is transmitting from one end to the another end. Okay, and important is this diameter. So diameter of the core is generally 5 to 10 micrometer. Okay, again it may vary this diameter, but I have taken the rough example. Okay, so this diameter also may vary, but generally it is 5 to 10 micrometer. Now one can imagine how much is the this micrometer range. So you can simply consider the thickness of your hair. आपके बाल का जो थिकनेस है, उस थिकनेस के बराबर का इसका डायमीटर है. ओके, कोर का बेसिकली. सो यू सी हाउ कितना थिन होगा कोर. ओके, सो 5 to 10 micrometer core will be there, and you see the cladding then. Now what is this cladding? So cladding is, again you see the core is surrounded by a medium, okay, with a low refractive index. Remember, core is the central part where the refractive index is maximum. Okay, on the top of that we are putting a material which we are knowing as a cladding, and that cladding is also having the refractive index but less than the core refractive index. Okay, now you must be thinking, or you may be thinking, why this core and cladding refractive index differences are there. So let me tell you that this particular optical fiber system is following the uh, a principle of TIR. Okay, total internal reflection. So light can be propagated, or light can be transmitted from one end to the another end through this process TIR. And now for this TIR there is a criteria that light has to travel from dense medium towards rare medium. Okay, so that is how you need to look it out. We'll discuss this TIR also in one single slide, but anyway, so to make it possible, this TIR, we are keeping the core as the maximum refractive index, cladding as slightly less refractive index compared to the core part. Okay, and you see the material, a cladding of a either a different glass material which has the less refractive index compared to the core. Okay, so and you see the diameter part, the diameter of the cladding is around 125 micrometer. So these are the some rough numbers. Okay, of course plus minus may be there, but around you see core will be around 5 to 10 micrometer, and this cladding diameter that may be around 125 micrometer. Okay, let me come to the next part. Now what is the role of cladding then? Okay, so that is one task, that to follow the TIR, we required less refractive index compared to the core. That is why we are placing the cladding. But again, there are few important roles of this cladding. Okay, so look at here one more time. So the first, it reduces the losses. Okay, whatever the loss of light, basically it will reduce it. So you can imagine, suppose if there is only core, no cladding, then light chances of losing the light will always be there. So that is why if you place the cladding on the top of that, then it will reduces the loss of light. Okay, because from core to the surroundings, as I said, if only core is there, then core to the surrounding loss will be there. But if cladding is there, then it can reduce, of course, this loss which is happening. Second is the scattering loss, okay, at the surface. So you see there are surface always, okay, whenever some these surface are in contact, so chances are there ki there may be some scattering at the core, okay, from the core or surface of the core. So it also reduces that scattering losses. And the third one, you see, it protects the fiber from absorbing the surface contaminant. So suppose if only core is there, okay, then chances are there that dust particle may stick to this core. Okay, dust particle or maybe some other surface related phenomena can happen with the core. So to protect your core part, because core is the main part of optical fiber that carries the signal, so to protect your optical fiber core, okay, so we are putting this cladding so that this contaminants part may not be stick to the core part. Okay, so wo protect karta hai. And the fourth one, you see, again it provides the mechanical strength also. So because as I told, core is having the diameter in the range of micrometer, 5 to 10 micrometer or something. So then again it may be very difficult to use that particular core, because it's a very fragile if this is the very thin wire or something. So that's why we are putting this cladding. So because cladding also serve the purpose of mechanical strength, so your wire optical fiber cable may not break it very easily because of this material. So these are the roles cladding is going to be play in the case of optical fiber cable. And again, jacket, third component, as I said, outer jacket or only jacket people are saying. So the role of jacket is to protect both core and cladding. Okay, तो दोनों को अगर मुझे प्रोटेक्ट करना है, then again an extra layer of safety I will put it on the optical fiber. Okay, so वो protect करता है. Now again you see it does not have optical properties. It may be, why? Because it is a just layer, okay, plastic cover or maybe something, so it may not have the optical properties. So roughly you see the around the size, this jacket part vary from 250 micrometer to 900 micrometer. Now why there is a so much large range for this? Because you see, as I said, in jacket there are again several components depending on the requirement, and you people are knowing that these optical fibers are buried uh, under so much depth, okay, in the earth. And even some of the optical fiber cables networks are there in the sea also. So to protect, okay, from all such things, okay, this outer jacket we are keeping it very strong so that your fiber may not be disrupted at any moment. Okay, break होने की chance काफी कम हो. That is why we are keeping it very high thickness for that particular jacket.
सर स्कैटरिंग कैसे हटाते सर?
स्कैटरिंग से सरफेस पे आप होगा, एजेस पे आप जब भी जाओगे किसी की, राइट, आपका लाइट अगर आप इंसिडेंट करोगे उसके ऊपर, कोर के ऊपर, तो उसके एजेस से जो लॉस होने के चांस है वो स्कैटरिंग लॉस हम लोग बोलते हैं। स्कैटरिंग कब होगा? जब एजेस से आपको लाइट स्ट्राइक करेगा तब। आर यू गेटिंग दैट? स्कैटरिंग तभी होता है, नॉर्मल केस में स्कैटरिंग नहीं बोलेंगे, स्कैटरिंग होगा उसके एजेस से। तो अगर आपने लाइट इंसिडेंट किया प्रॉपरली, आपका इंसिडेंट होने के बजाय उसके एज पे अगर टकराता है, देन चांसेस है कि स्कैटर्ड हो जाए आपका लाइट। ओके, तो स्कैटरिंग लॉस रिड्यूस करने के लिए भी हम लोग क्लेडिंग ही यूज करते हैं। क्लेडिंग ये सारे बेनिफिट आपको प्रोवाइड करता है। इज इट क्लियर नाउ?
Yes, sir.
Okay, then you come to the next. Okay, here is the that principle which I was talking about. Okay, and you also know that. So let me describe it in one single slide. Already you people are knowing that. So you see this core part, which is the central part. Okay, and on the top of that you see ये जो yellow color का layer दिख रहा है, that is your cladding, and you see the central part. I have made it larger. I mean, in the diagram you see it is larger because we need to discuss all such phenomena over here. So purposefully we have kept larger. So core part, and you see the central part of the core also one can define with this dotted line. Okay, dashed line, and then you see this angle, etc., all such stuff. Okay, so you people are familiar with that. What happens if the light is moving through that? And you see this is the core, that is dense part, and cladding is having the slightly less reflective index compared to the core part. So if so, that means if light is moving from dense medium to rare medium, then what will happen? So all such cases they have considered. This is the general case. Okay, strike directly, and if it is making certain angle, then it is going to bend. But if it is, you see now you people are knowing that angle. Okay, so this angle is 90-degree. Okay, you make it,
More than critical angle.
yes, more than critical angle, so that it will pass it straight, it will. Okay, but अगर वो critical angle से ज्यादा हुआ, then only it will be coming down to this one. Okay, otherwise it will move parallel, but if it is more than critical angle, then only it will come down to this. Okay, bottom side, and that's how this process is going on several times. Every time it has to follow this only. Okay, so for clarity again,
striking, they should lose energy, no?
no, because glass is the medium where the chances of absorbing or reflect or absorbing or transmitting case is very limited, very less, almost negligible, and that is why they are using the cladding material as a glass. Okay, क्योंकि glass में property, will discuss definitely that part also, we are going to cover why glass only we are going to use and why not some energy losses. And of course some amount of light will be losses everywhere, and that is why we are getting some loss, even though you see 0.2 dV per kilometer also we are getting. So why we are getting? Because of this only. Okay, क्योंकि कहीं ना कहीं आपका लाइट एब्जॉर्ब हो जा रहा है, बट वो चांसेस काफी कम है कंपेयर टू एनी अदर मटेरियल. The chances are, or the probabilities of getting losses is very less in the case of glass. Okay, so you see again on the right hand side I have written carefully. So critical angle is defined as the value of incident angle at which the angle of refraction is 90-degree. Okay, so अगर वो 90-degree होता है तो ये parallel होगा, but if it is more than that, then of course you will see that light is going on, passing on through the optical fiber. So that's how the general principle we are already knowing. And now let's coming to the next criteria for TIR. Okay, so these are the two criteria to fulfill. The first one, let me annotate for you people. The first is the refractive index of the core. Okay, it must be greater than the refractive index of cladding. So as we know that discussed already. And the second is the light must approach at the interface with an angle of incidence phi that is greater than the critical angle. Okay, so angle of incidence has to be always greater than critical angle, then only the light can be follow the TIR pattern. And this is how you define the critical angle. Sin phi c equal to n2 by n1. N is the, sometimes people are saying eta also, but I will prefer to say n. So n2 is refractive index of cladding, n1 is the refractive index of core. And keep in mind these are the default, by default we are considering the naming that whenever you see n1, that means we are talking about the core refractive index. Whenever you see n2, that means we are talking about the cladding refractive index, until someone specifies what is n1 n2. अगर नहीं दिया है, that means by default आपको n1 refractive index core के लिए लेना है, n2 आपका cladding refractive index होगा.